All right, this lesson is on correlation and causation, and this is the first video for it. What correlation and causation is you should have learned this from the previous lesson, and if you haven't and you're just checking this out now, it means that there's two variables that appear to have some kind of a relationship with each other. All right, and usually they can determine that there's a relationship with each other, and in the instances we're talking about, because they seem to form a linear, they form a line. When they have a linear relationship. Sorry, I'm trying to say this in a smart way and I sound like a ding-dong. So if you've got something that is a correlation, you can kind of assume for the purposes of this lesson that means it looks to make some sort of a line. Right? So it would be making a negative or a positive correlation, you know, going up from left to right or going down from left to right. And so what we're going to talk about is what's the difference between just having a correlation, so in other words, they appear to be related somehow, but maybe we're not sure, as opposed to causation, which is not only are they related to each other, they appear to be related to each other, but one seems to be causing the other one to do what it does. All right, and so there's different cases and things to consider about this, and I think as we start looking at some examples that will start making sense to you. So if I look at this, the form of the definition in the book is it says sets of data can show a relationship or a correlation even when the variables are not related or dependent upon each other. Because of this, correlation does not prove causation. In other words, if two things seem to form some sort of a linear relationship on a graph, that doesn't necessarily mean one causes the other. All right? So it's important for us then to determine whether one variable is causing the other to change or if the data just shows a correlation, right? And the statisticians do this all the time, and they have these coefficients and these things they use to help with that. So let's look at this from situation to situation. So it says, determine whether each situation illustrates correlation but not causation, or causation. All right, so in letter A, it says, Rebecca records the pounds of each type of vegetable her garden produces each year. She discovers a negative correlation between the pounds of sweet potatoes and the pounds of spinach it produces. And the book goes on to say, it models correlation but not causation. All right, and then it gives its answers for this. And if you think about that, there's so many other factors at play that could affect that, right? It could be that maybe, it's assuming that you're growing the same number of each, right? Maybe it has to deal with the weather, right? Maybe it has to deal with your soil. Maybe it has to even deal with the type of seeds you get, and it's just been a coincidence. I mean, so there's so many different factors that could affect it. So it would be probably not wise to say that it is causation. So that would be correlation, not causation. And then the next one is police report states there's a positive correlation between the number of days it snows and the number of car accidents annually. And if you think about that, that should be kind of a no-brainer, because if it's snowing, it's going to create slippery conditions, and in slippery conditions, there are obviously more accidents. So not only is there a correlation between that, but there's probably causation for that, right? People aren't just randomly crashing into each other on when it's snowing. Just because they decide to crash into each other. They're crashing into each other because of the conditions, and the conditions are due to the snow. So the snow is causing it, and therefore it is called causation. All right, so if we look at a few other examples. All right, smaller the size of a person's palm, the longer a person's life expectancy. So they're saying there is a correlation between this, but to say that you have causation would say that because a person's palm is smaller, they're going to live longer. And if you think about that, that's kind of ridiculous, because there's so many other factors that go into health, right? You think about, what do you eat? What's your exercise regimen? Do you smoke? Do you drink? all, hereditary factors. Do you have heart disease? What's going on? Things that have nothing at all to do with the size of your palm. So you could say, correlation, but not causation, right? So correlation, or we'll say without causation, because that's easier to write. Next one, the larger a person's shoe size, the higher a person's reading level. Obviously, maybe there is a correlation there, but definitely not caused by that, because I know plenty of people with large feet who maybe don't have as high a reading level as somebody with smaller feet. Think of what does that say about, about people who naturally have smaller feet, like women, right? So just no way. Correlation, again, without causation. All right, car insurance, the more car accidents a person is involved in results in a higher rate for car insurance premiums. Absolutely, because that's how they calculate your premiums, is based upon your activity and whether or not you are getting in accidents, and other factors as well. But that would definitely be a case of causation. All right, and then this last one, the lower the daily high temperature results in a greater number of customers that purchase a ticket for the ski lift. Now, you think about why people would purchase a ticket for a ski lift. It's because they're going skiing. All right, so in order for there to be skiing, there needs to be snow, right? And it also has to, but there's other factors. So I would say that there is maybe a little bit of causation here, but not enough for you to say that it rules everything else out. Because what about whether it snowed or not? Because usually a lot of people like to go skiing after it has snowed, regardless of the temperature, right? Obviously it's in a range or the snow would have melted. But sometimes people ski when it's 35 degrees and they might be more apt to go out because they know there was a fresh powder cover, as opposed to when it's 5 degrees, when it's cold. And with a wind chill, they might want to stay home and not be out on a cold ski hill. So I would say for that one that while there's definitely a correlation and it might play a factor, it is not the only factor. So it would be correlation without causation. So hopefully these kind of get you thinking about this and sort of illustrate the differences between the two.